this video, we'll look at one more example from section 6.1 that's a little bit different from the others. So these are the slides of section 6.1. And the example that I'll do is, it has to do with the mean and interpreting the mean as an expectation. So I have some separate notes right here that summarize it. So the mean for a discrete probability distribution can be found using this formula, and there's also a way to find it on a graphing calculator. This came up in an earlier problem. And also remember from an earlier problem that the mean is often interpreted as an expectation. So if you see words like expectation or expected value or expected amount in a problem, that's probably referring to the mean. And this example, number 27, is similar to what you'll see in one or two of the homework problems. And the problem is that a life insurance company sells a $250,000 one-year life term policy to a 20-year-old female for $200. So she purchases this for $200 and then gets this policy. Also, according to the National Vital Statistics, the probability that a typical female would survive over the course of a year is 0.999544. So that's the chance that a 20-year-old female would live over the course of the year. It's a pretty high probability. And then they want us to compute and interpret the expected value of this policy from the perspective of the insurance company. So one thing to point out is this problem mentions expected value, and when you see that phrase, that means that ultimately you'll want to find the mean. So ultimately you just have to calculate the mean of this variable. So to find that mean, sometimes it's helpful to construct a probability distribution. Just make a table to summarize all the information. And so two columns of that table would represent the x and the probability. One thing is to figure out what is x representing, and that's going to represent whatever they're asking about in the problem. They're asking about the expected value of that policy to the insurance company. So that's a monetary value. So our x is going to be the monetary value. And then the other column is the probability. You also want to think about what are the different outcomes that could happen in this situation. So this person purchases an insurance policy, and from the insurance company's perspective, the two outcomes that would affect them would be whether that person is okay and lives over that year, or whether that person dies over the course of that year. So the two outcomes would be that either the person who bought the insurance survives that year, and then the other outcome would be if that person does not survive. So if the 20 20-year-old female who purchased the policy, if she survives, from the company's perspective, they would profit $200. They would just take $200 and that's it. And so that would be the value in that case to the company. And the probability of that happening is 0.99544. That's the probability that a typical 20-year-old female would survive. So 0.999544. In the other case, if something were to happen and she died that year, the insurance company would pay $250,000 to her family. So from their perspective, they would be losing $250,000, and they would still have the $200 that they obtained originally. So we could write it as they would still have gotten the $200, but then they give out $250,000. So that's like minus $250,000. And overall, it's going to come out to a negative. It's a loss overall. So negative $249,800. Whoops. For the probabilities, the probability that she would survive is 0.999544. The probability that she would not survive that year is the complement of this. So 1 minus 0.999544, which is going to be 0.000456. So now this is filled out, we have this information, and the last thing is to calculate the mean. That was the whole purpose of making that table. The mean can be found by multiplying every x value times its probability. So the first one is 200, is the first x value, times its probability of 0.999544, and then plus. The next x value is negative, so it's plus negative 249,800 times its probability of 0.000456. And so we'll work that out, and let's see. It comes out to 86. And remember that that represents the monetary value. That's the expected monetary value. So 86, and the interpretation is that for a randomly selected ~20-year-old female, the insurance company can expect to profit on average $86. Just one other note that I worked out this mean by using the formula, but if you are comfortable using a graphing calculator, you can find that by using a graphing calculator, and I put the the notes for that on these notes also. Alright, we'll move on to section 6.2.